Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on van der Waals forces. In our last lesson, we discussed hydrogen bonding. We learned that it is a particular type of intermolecular force that occurs when a hydrogen atom is bonded to highly electronegative elements such as fluorine, oxygen, and nitrogen. We also learned that hydrogen bonding is stronger than ordinary dipole forces. While dipole-dipole forces are only about 1% as strong as covalent bonds, hydrogen bonds are about 5 to 10% as strong. In today's lesson, we will begin discussing van der Waals forces. We will explain dipole-dipole forces, and we will look at some examples of the molecules of this type of force. Students, let us begin this lesson with a quick review activity. Previously, we learned about intermolecular forces. Please define this term and then list the 3 types of forces that it encompasses. Write your answers down on a piece of paper, and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure that you had no trouble with this activity. You are correct to define intermolecular forces as the relatively weak forces of attraction that occur between molecules. The three types of force that fall under this classification include dipole-dipole forces, London dispersion forces, and hydrogen bonding. Is that what you wrote down, students? If so, great job! Dipole-dipole forces and London dispersion forces are collectively known as van der Waals forces. Named after a Dutch scientist named Johann Diederik van der Waals, this force is the sum of the attractive or repulsive forces between molecules. This excludes the forces between molecules that are due to covalent bonds. It also excludes forces between molecules that result from the electrostatic interaction of ions with one another or with neutral molecules. Dipole-dipole forces are strong intermolecular forces between polar molecules. Dipoles are created by equal but opposite charges that are separated by a short amount of distance. In other words, due to an unequal sharing of electrons, some atoms are slightly negatively charged, while others are slightly positively charged. This results in an attraction between them. Polar molecules act as small dipoles. This is because of their uneven charge distributions. How do we represent dipoles? They can be shown by drawing an arrow with the head pointing in the direction of the negative pole and a cross tail positioned at the positive pole. Let us look at an example. This is a dipole that has been created by hydrogen chloride molecules. As you can see, its negative end is located at the more electronegative chlorine atom. In both liquids and solids, the negative end of one polar molecule attracts the positive end in an adjacent molecule. Dipole-dipole forces take place in molecules such as ethyl alcohol and water. Students, try to draw your own diagram of the dipole-dipole forces in either a water molecule or an ethyl alcohol molecule. Begin now, and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I wonder what your diagrams look like. Please compare your diagram to those that are on the screen. Make any necessary corrections. If you are confused or you require assistance, please ask your teacher for help. Dipole-dipole forces have strengths that range from about 5 kilojoules to 20 kilojoules per mole. While these forces are strong between the polar molecules involved, they are actually quite weak in relation to ionic or covalent bonds. They also only have a significant effect when the molecules involved are so close together that they are nearly touching. We have time for one last activity. Let us complete several sentences regarding dipole-dipole forces so that you can test your knowledge. In a moment, you will see sentences appear on the screen, one at a time. Please fill in the missing words.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. Were you able to complete each sentence correctly? Let us do it together now. Dipole-dipole forces and London dispersion forces are collectively known as van der Waals forces. Dipole-dipole forces have strengths that range from about 5 kilojoules to 20 kilojoules per mole. In both liquids and solids, the negative end of one polar molecule attracts the positive end in an adjacent molecule. Dipoles are created by equal but opposite charges that are separated by a short amount of distance. Great work, everyone! In today's lesson, we discussed dipole-dipole forces. We learned that these forces, along with London dispersion forces, are collectively known as van der Waals forces. We discussed that dipole-dipole forces are strong intermolecular forces between polar molecules. Individually, dipoles are created by equal but opposite charges that are separated by a short amount of distance. We also learned that dipole-dipole forces are relatively weak in comparison to ionic and covalent bonds. This brings us to the end of our lesson for today. In our next lesson, we will learn about London dispersion forces, which, as you know, is the other type of van der Waals force. We will also compare and contrast all of the intermolecular forces we have studied in the last few lessons. Until next time, thank you, teacher. Thank you, students.